Hey, here we go, geometry students. Welcome to chapter 10. We're getting very near the end of the year. This is exciting, near the end of our textbook. So here we go. First lesson of chapter 10, and we just finished a chapter on area in terms of 2D shapes. And so we're moving into the third dimension. And they call that in this lesson solid geometry. So 3D shapes. So it's about to get exciting. Fasten your seatbelts. A whole host of definitions for this one. So that makes make sure we know all of the terms for 3D shapes. So let's start off with these first three, face, edge, and vertex. All right, so when talking about a 3D shape, this particular prism here that I've drawn, beautiful. Okay, so we have here a prism, which is a type of 3D shape that we'll define in just a minute. We want to make sure we know the difference between faces, edges, and vertexes. So faces are any of these flat surfaces. So this right here on the top, or maybe you could even the back side over here. Those would be your faces. Might also call them sides because they can be the top and the bottom. We call them faces. Okay. Then your edges, that's just where the faces intersect. So that's pretty straightforward here and here. Those are your edges. Okay, and then your vertex, we should already know what vertexes are. They're basically the corners. And so any of these meeting places here, those would be your corners. Oh, not your corners. Those would be your fancy word for corners. Those would be your vertices. If we go plural, we spell it like that. Okay, so those are your vertices. Right, so whether edges, faces, or vertices, that's what we're talking about. The other thing I'll point out is that the bottom and the top, and we'll talk about this in a second, the two parts that seem to be that you could set the thing on or that are parallel to each other and congruent, those are called your bases. I didn't make that a vocab word, but you do want to make sure you know how to identify the base of the prism. And you'll see why, because that's really key to, one, when we get into finding the area or the volume and the surface area of these things, as well as identifying them, classifying them. So let's go ahead and look at different types of these 3D shapes that all have these combinations of faces, edges, and vertices. You have a prism. And so a prism is specifically formed by two congruent bases connected by parallelogram faces. So that the object up here, that's a prism because you have the two triangular bases that are congruent, and then they're connected by the side faces that are all, notice they're all parallelograms. They're all what we call rectangles or squares. They could be parallelograms, they could be squares, rectangles. So parallelograms, the best term for it. And so your bases are always that congruent shape, then linked by the parallelogram faces. So, like for example, another example of a prism could be something like this. Make one a little fancier. Say you had a whatever that is, hexagon. And so you could have, and as long as you have two of those, they have to be congruent, the same size, and then they're connected by parallel lines. Those back ones don't look very good. I'll just make them solid. Okay. And so again, the way that you classify this is based on its basis. So we can see what shape are congruent and parallel. They are hexagons. So this would be a hexagonal prism. Okay, and notice all the sides going around, they're all basically rectangles, technically parallelograms. Okay, so that's a prism. It's very specific. It does. Some people use prism as like any sort of generically 3D shape. No, it has to have those congruent bases. Then we get to a cylinder, and all a cylinder is a circular prism. That's what I'm going to call it. So circular prism, it's formed by two congruent circular bases, and then the surface on a cylinder is curved. It doesn't have the flat rectangular one. So we draw ourselves a nice little cylinder. Okay, your beautiful toilet paper roll. Circular bases. That one line doesn't look very good. Okay. And then notice it's a curved one surface face all the way around. Again, pretty much a prism, but if we have a circular base, it gets its own special name because it's going to have special formulas for its volume, and so we call that a cylinder. Then we get to a pyramid. A pyramid has a polygonal base with triangular faces meeting at a common point. Now, you know what a pyramid is, but we're trying to be a little more technical because there's maybe more types of pyramids than you would expect. But it has some sort of a polygon base. In this case, why don't we make it a we'll make it a trapezoid. Okay, so it's got a polygonal base, and then all the sides, rather than going vertical and parallel, or I'm sorry, perpendicular and parallel, they all have to meet at a common vertex. So if I make my vertex here, so then here we just go to connect all these points, and I can see that I have that doesn't look very good because the line matches so much up with. Yeah, we'll do something like this. Yeah, looks a little better. Okay, that's a pyramid. In this case, it would be a trapezoid-based pyramid. Notice in this case, as it said, the sides are triangles, not parallelograms or the curved one of the cylinder. Okay, and you can have a pyramid of all. We're most likely think of the Egyptian pyramids with rectangular or square bases, but like mine, you could have a trapezoid, you could have an octagon, you could have all sorts of bases. And just like with the cylinder, if you happen to get a circular base, then you get a special name for that. We call that the delicious snow cone or ice cream cone. And so that's just a pyramid, but when the base happens to be circular. Not necessarily a perfect circle, could be an oval, but a circular base. And then again, the sides all meet up at a common point. Okay, so those are your basic 3D shapes: cone, pyramid, cylinder, and prism. I want to make sure you can tell the difference between those. And then a net. A net is just a representation of a 3D figure that could be folded into the shape. So the most simple example would be, say I had a little cube here. This would be that'd be a square prism, or if I didn't draw a perfect square, a rectangular prism. And so a net would be, what happens, imagine that was a piece of paper and you unfolded it, and so it would look something like this. So that could be a net. Now, in this case, notice this is 3D, and this here is 2D. And it's, imagine along all those squares, you folded it. You could fold the first 4 to make the sides, and that top one would come right on the top and create the top. And so a net represents a 3D figure as though it were in 2 dimensions and kind of like unwrapped or broken down. And we'll be doing some exercises with those. And lastly, cross-section. What is a cross-section? Cross-section is the intersection of a 3D shape and a plane, or the idea of maybe taking a slice from a 3D shape. So say let's go ahead and do a cone. And then if you imagine that you then took a sheet of paper and sliced through that cone. Okay, this is 2D. The cone is 3D. And usually what it attempts to ask yourself is what kind of a shape is created if you were to take a slice. If you were to take a slice of a 3D shape, okay, so we call it a cross. Just like you cut a cake and you see the cross section of the cake, or something like that, or a house. You might see cross sections of house. You have a 3D house, but it's cut in such a way so you can see it as a flat 2-dimensional view. Okay, so we're going to be looking at cross sections as well. So now let's go ahead and take a look at just 3 questions, 3 basic distinctions I wanted to emphasize. What's the difference between a prism and a polygon? Okay, well, a prism has some sort of congruent base and bases that are then connected. And of course, it is 3-dimensional. Whereas a polygon, you could have the exact same triangle, but it only exists in 2 dimensions. So when we say polygon, we're talking about a 2D. Let's just do this. We're talking about a 2D shape. It has length and width. But when we talk about a prism, we're talking about the type of shape that is going to be in 3 dimensions, length, width, as well as height. Okay, so you get an added height when it comes to prisms. When we talk about the difference between maybe we'll add that. We got length, oops. length, width, and height. Whereas here, we simply have the length and width. Okay. So now prism versus cylinder. Okay, we already just talked about that. They both have congruent bases. Oops. They both have congruent bases, but a cylinder is a prism with a circular base. Okay, so here we've got our circular bases. So there's our cylinder. Oh, they got to be congruent though. Let's try to make them congruent. So there's our cylinder, and here we have the circle, the circular base, whereas the prism would be any other shape, you know, and again, just make it real simple like this. And again, they're supposed to be congruent. Sorry, this one's a little sloppy, but I think you get the idea. Okay, that's actually not a prism. Maybe if we're looking at it at a fun perspective, looking down, but the top and the bottom are supposed to be congruent. Okay, so the big difference is the circular base. Okay, whereas the other one, we could go ahead and say that's a polygon base. Okay, almost done. Difference between a pyramid and a cone, same idea. They no longer have the parallel bases, but the pyramid has a polygon base. Okay, so let's just pick. We'll do a. Why don't we do a? Oh, that looks horrible. Something like that. That looks pretty bad too, but oh well. And so it's got some sort of shape that is the base. Could also just be something as simple as this. Okay, whereas the cone again has the circular base, but rather than having the congruent top and bottom, they have the common vertex at the top, some sort of circle, and so that's the key difference there. Okay, so mainly a chapter on classifications, not too tough, no real calculations, but we want to make sure we know our vocab and make sure we can classify and begin to talk about these things correctly, as well as understand some of the more nuanced distinctions between them. All righty. Look forward to having you in class and going over all this and finishing the year out strong. See you soon.